So we've got our giant triangle with 3 pieces of information given, and we need to solve for all of our missing sides and the area. Almost forgot to add that as one of our things we're solving for. The area. So we got all the things we need to solve for on that right side over there, and then we have our diagram over here. Now, there is a bunch of different ways to solve for any of these values. I'm just going to show you one way for each one, but that doesn't mean you have to use that same exact method when you do it. Use whatever makes sense to you, and just make sure that you're utilizing all of your resources. So think about the options you have and pick what you think works best in the moment. So to start, I'm actually going to solve for A over here, because we can use triangle angle sum. So this is, we got 2 right triangles over here. So we have 180 minus 90 minus 67, that's going to be equal to A, which means that A is equal to 23. A is equal to 23. So we've got the first one already done, just by using triangle this up. So to make things a little easier, for each value that we solve for, I'm just going to erase the variable that was there, and then I will put the solved value in a different color. So now we know all of the angles in this triangle over here. Now we need to solve for x and y. To solve for x, I'm going to use sine. So we're going to take the sine of 67, and that's going to have our equation set up to the opposite side over the adjacent, so that's going to be 5 over x. We're going to multiply x on both sides. Those are going to cancel out. And then we're going to divide sine of 67 on both sides. Those are going to cancel out. And we're going to get that x is equal to 5 over sine of 67, which is equal to, and we're rounding to the nearest tenths place while we're doing this. So we got 5.43, that will be 5.4. And that was for our x value, so we'll get 5.4 over there. Now there's a couple different ways we can solve for our y value. I'm going to do cosine, not cosine, tangent, just because I don't want to do squares. But you can use the Pythagorean Theorem to solve for y over here. But I'm just going to use tangent. So tangent of 67 is going to be equal to 5 over y. And we're doing all of the steps that we just did over here in that order, just a little different. So we multiplied y on both sides to get rid of the y at the bottom of the fraction. Then we divided tangent 67 on both sides to get rid of the tangent over here and make y by itself. That leads us to have our equation as y is equal to 5 over tangent of 67. We'll plug that into the calculator. And that's going to get us 2.12. We will call 2.1. Now, I think if you use if you use a different, if you use cosine in this case, or the Pythagorean Theorem, you should also get 2.1, but one of them is going to get you just 2.0. That's close enough where it will work, so I'll put that over here, because we can utilize that later. Yeah, you can get 2.1 in two cases, and then 2.0 or just 2 in one case. So I will use 2.1, but when we calculate the area later, I'll use both of them to show you what values you could possibly get. All right. We found all of our missing information on this triangle, so now we're going to move over to this one over here. Now, there's a couple different ways we can start. The first thing I'm going to do is solve for our missing side z over here, and we'll use the Pythagorean theorem for that. So remember, that's a squared plus b squared equals c squared. A and b are our two legs, and c is our hypotenuse. So we'll say 5 squared plus z squared is equal to 7 squared. We're going to get 25 plus c squared is equal to 49. Then we're going to subtract 25 from both sides. We're going to get z squared is equal to 24. Then we're going to use square root to cancel out the square over here. We're going to use on both. We have to use it on both sides. And then z is equal to the square root of 24. And when we plug that into the calculator, it's going to simplify into 4.898. And it's just a bunch of high level numbers, so we're going to round that up to 4.9. Yeah, I have z is equal to 4.9. Oh, I forgot to put y over here. Oh. Made a mistake, accidentally put the 2.1 and 2.0 where c was, so I just erased that. So this should be the correct position now for our values. We have a is equal to 23, x is 5.4, y is 2.1 or 2.0, and z is 4.9. So now we can solve for B or C. Let's do C. So we have 3 possible options to solve for C. We can, since we have all of our sides given to us now, we can use tangent, which is our opposite and adjacent side. We can use sine, which is our opposite and hypotenuse sides. Or we can use cosine, which is our adjacent side and our hypotenuse side used. I'm going to use sine just because I like the whole numbers. So we're going to do sine of C, that's the angle we're looking for. That's going to be equal to the opposite side over the hypotenuse. Now we need to solve for C, which means we have to use some inverse trig. We're going to apply our inverse sine function to sine so that they cancel out. And if you do that on one side, you need to do that on the other side. Those cancel. We got C is now equal to inverse sine of 5 over 7. Okay, we plugged that into the calculator and we got 45.584. We're going to round it up to 45.6. C is equal to 45.6. Now I did want to let you guys know that if you used any of the other methods, so if you used tangent and you used 5 over 4.9 as your ratio, or if you use cosine and did 4.9 over 7 as your ratio, and you did the steps correctly, you should still get 45.6 for any of those options. And now we're solved for B. B, we can use either one of the inverse functions, or we can use triangle angle sum. Since we already used our triangle angle sum over here, and we use one of the inverse functions here, we'll use another inverse function, just a different one. So this is 45.6. And for B, we'll use cosine. It doesn't look like we've used cosine yet, so we'll use cosine. Remember, B is our reference angle, so cosine of B is going to be equal to the adjacent side, which is 5, and then over 7, which our hypotenuse is. That's how it matches up. We want to solve for B, so we're going to use our inverse cosine function to cancel out cosine. And if you do that on one side, you got to use it on the other side. Those will cancel out, and we'll be left with B is equal to inverse cosine of 5 over 7. Now when you plug that into the calculator, you should get the exact complement of this value over here. So it's going to give us 44.415. That's going to round to 44.4. So now we've solved for every angle in this triangle and every side in the triangle. Last thing we need to do is now solve for the area. So as a reminder, your area is going to be equal to the base of the triangle times the height of the triangle divided by 2. So this whole value here is our base, and this value here is our height. So we're going to add up 2.1 and 4.9. That's going to give us 7. So that's going to be 7 times 5 divided by 2, which is going to be 35 over 2, which is going to be equal to 17.5. Now, if we had used, if you had used one of the methods, you got 2 as your y value. So let's say this is 2.0, or just 2, and we apply it into the same equation. We're going to get that the base is 2 plus 4.9, which is going to give us 6.9 times 5 over 2. 6.9 times 5 is going to give us 34.5, so it's a really, really small difference over here. But when you take that number and you divide it by 2, you're going to get 17.25, and if we round up, that'll give us 17.3 as our area. So we made a slight change over here. We got 2.1 to 2.0, and that affected our area in the 10th place by about 0.2. It's a small difference, but it is a small enough difference where it might change your answer. So this is all the work done, going from solving for the angle A, solving for side X, solving for side Y, solving for side Z, and then angle C and angle B. Here's all of our values. That's our triangle, and here's how we solve for the area. So I'll give you guys some time to take a look, just take it all in. I know it's a bunch of information on the wall right now, so please, please, please go at your own pace. And just for reference on all the different ways you could possibly do it, this is a lot of stuff, but if you really, really want to test out a bunch of different methods, this is what I did last night. I was testing a bunch of different methods to solve for each value, and I missed a couple. So you have a lot of options to solve for different sides and angles. You have a lot of options. It just depends on where you start.